the rectangle, the rhombus, and the square. So this video will cover additional special parallelograms and special quadrilaterals. So what makes the rectangle the rectangle? And all four of these are quadrilaterals. So we know they have four sides, four angles. The rectangle is the quadrilateral with four congruent angles. Or I'll just say all angles congruent. The rhombus is the quadrilateral or the four-sided figure, the four-sided polygon, where all sides are congruent. And the square is the polygon, the four-sided polygon quadrilateral, where all sides and angles are congruent. Now, because all angles are congruent, and we know the polygon interior angle sum is 360 degrees, because we can think of the polygon with four sides, we can divide into two triangles, each 180, so in total 360. If they're all congruent, then each one must be 90 degrees, and therefore the rectangle can be identified through four 90-degree or four right angles. Now, because all angles are congruent, that means opposite angles are congruent, and if opposite angles are congruent, then we have a polygon that represents a parallelogram. For the rhombus, if all sides are congruent, then opposite sides are congruent, and that is again a condition for a parallelogram. So the rhombus is a parallelogram. And then if the rhombus is a parallelogram, the rectangle is a parallelogram, then the square is as well for the same reasons. So we'll make a note that the rectangle, the rhombus, and the square are parallelograms. So the properties of the parallelograms apply to the rectangle, rhombus, and square as well. Now, what's a separating factor aside from all angles being congruent of the rectangle? What's a way that we can identify it? Well, if we have a rectangle, let's draw one. All angles 90 degrees. If we know this is also a parallelogram, opposite sides are congruent. And if we introduce the diagonals, notice the diagonals are going to be important for identification. We can separate or identify some triangles that occur when we introduce the diagonals. So I'll assign some letters to make this more clear. Let's say that this is A, B, C, and D. And we have A, B, and D. And then we have A, D, and C. Not B, D. So these two triangles are congruent by side angle side. So by CP/CTC, the hypotenuse of each right triangle that I've removed are congruent. And what do those hypotenuse represent? In my rectangle, they represent the diagonals. So in a rectangle, the diagonals are congruent. And we're going to use that as one of the main ways, or one of the more efficient ways, to identify if a quadrilateral is in fact a rectangle. So remember, diagonals are congruent. Let's add that here. So the diagonals being congruent is not a property of the parallelogram. The only thing we know about diagonals in a parallelogram is that they bisect each other. Now let's look at the rhombus. So the rhombus, quadrilateral, four congruent sides. Let's take a look at these diagonals here. We know that the rhombus is a parallelogram. So by the properties of the parallelogram, the diagonals get bisected. And if they get bisected, you'll see that there are these four subtriangles that are all congruent to each other by side, side, side. So let's look at the top two triangles that are adjacent to each other. If they're congruent by side, 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 then corresponding angles are congruent, okay, by CP/CTC. So those two angles I've marked off with the blue arcs are congruent to each other. They also form a linear pair. And we know that a linear pair is supplementary. And if we know that we have a congruent linear pair, each one must be 90 degrees. So extending upon that, if those two angles are actually in fact right angles, then this is a right angle and that's a right angle. So what did we just learn? The diagonals are perpendicular to each other for a rhombus. Again, not necessarily true for the parallelogram and not true for the rectangle. So that's a defining feature of the rhombus. Again, that's one of the things we're going to look to use to identify a rhombus when we're given a shape that we don't know exactly what it is right off the bat. Now, what else happens? So through the same reasoning of CP-CTC, knowing that corresponding angles are congruent, because these are all the same triangle, these four subtriangles, what I'm marking off are congruent to each other because they're in corresponding locations. And by marking this off, we now see that the diagonals not only run perpendicular to each other, but they bisect the angles of the rhombus. So now, the square. How do we identify the square? Well, we will have a square if we have a rectangle and if we have a rhombus. So that's that. So now, let's go over to a problem where we have this quadrilateral in a coordinate plane, and we want to identify how we can classify this thing. Now, the most efficient way to do this is by working with the diagonals. There are only two diagonals. I can use the angles, I can use the sides, that's fine, but there's four angles and four sides. So you tell me what requires less work, because they're going to involve calculating lengths and calculating slopes. So if all I have to do is work with these two lines, that's going to make my life easier, less work. So the first thing we want to do, let's check to see if we're dealing with a parallelogram. Okay? If we're dealing with a parallelogram and we want to work with the diagonals, we know that parallelograms, the condition is if the diagonals bisect each other. How can we verify if they bisect each other? Well, a line is bisected by another line if that line passes through its midpoint. So for them to bisect each other, they must both have the same midpoint. So let's first check bisection of diagonals. And this is for the parallelogram. So we want to check, do we have a parallelogram? So we're going to check same midpoint. So calculating the midpoint. Let's do midpoint of BD. So to calculate a midpoint, average the x's, average the y's. And we're going to get 1/2, 7/2. So now let's do midpoint of AC. We're going to do -1 plus 2 over 2 and 7 plus 0 over 2. We're going to get 1/2, 7/2. So same midpoint. So check, we have a parallelogram. Now that's big, because if we have a parallelogram, then now if we check the diagonals are congruent, we'll know we have a rectangle. And if we check the diagonals are perpendicular, we'll know we have a rhombus. By the way, if we jump right to checking if the diagonals are perpendicular, that doesn't necessarily guarantee a rhombus. We could have a kite. Well, we can see that these diagonals are going to run perpendicular to each other, but not all sides are congruent. So we want to verify that we have a parallelogram first, because that guarantees that the opposite sides are going to be congruent. And then if we know the diagonals are perpendicular, I now know I'm not dealing with a kite. So check the parallelogram condition first. Next, if you do the rhombus or the rectangle next, doesn't matter. So let's do rectangle. So diagonals congruent is going to be our rectangle. Again, another way we could check the rectangle, we could see if we have 4 right angles, which would require we check slopes of sides to see if they run perpendicular to each other. Or we could just look at these 2 lengths. So how do we do this? There's 2 ways to calculate the lengths of lines in the coordinate plane, one of which is using Pythagorean theorem, the other is distance formula, so I will use both. Pythagorean theorem requires you to draw a right triangle, count off the sides, 3, and 7, and then use Pythagorean theorem to find the hypotenuse, which is synonymous with the length of AC in this case. So let's set that up. AC is our hypotenuse, which is what we're looking for in our triangle. So the hypotenuse squared should equal leg squared plus leg squared. So AC squared is 9 plus 49 is 58. So the length of AC, using Pythagorean theorem to find that, is square root of 58. Now let's check the length of BD. So we'll say BD, the distance from B to D, using distance formula, should be the square root of the difference in the x values plus the difference in the y values. We're going to get negative 7 squared, which is positive 49. 3 squared is 9, so square root of 58, check, check. Both diagonals are equal in length, and therefore we have a rectangle as well. So we verified the parallelogram. We verified the rectangle. Now let's check for the rhombus. So calculating distances, we can use Pythagorean theorem by drawing your own right triangle, or you can use the distance formula, which is really just derived through Pythagorean theorem. So now, diagonals perpendicular, this is going to get us the rhombus verification. And again, this is after we've already verified the parallelogram. So now to get diagonals perpendicular, we're going to be looking at slopes. A couple ways to do slope. We can do slope formula. So I'll do that for AC. So the slope of AC, we're going to do change in y over change in x. So I'll actually use this computation. And then for the slope of BD, we'll count off rise over run. So you can look at both ways. So change in y. If I'm going to go from C to A for my change in y, I must also go C to A for my change in x. So just make sure you stay consistent. So minus the negative 1 makes a positive 1. So we're going to have 7 over 3 for our slope of AC. For the slope of BD, we'll count rise over run. When you count rise over run, if you have a if you're going up in your rise, it's positive. So positive rise is going up. Going down is a negative rise. If you're going right on the run, it's positive. If you're going left on the run, it's negative. So it all depends on what point you're going to from where you start. So if we're going from B to D, my rise is going down, so it's going to be a negative 3, and my run is going right, so it's going to be a positive 7. But if I went from D to B, my rise would be a positive 3, and my run would be a negative 7. Either way, we get the same slope. It's just the negative sign is in the numerator instead of the denominator on one or the other. So if we do rise, negative 3 over run, positive 7. So if you're going to count, just keep that in mind. Going down, the rise is negative. Going up, the rise is positive. Going left, the run is negative. Going right, the run is positive. So we're going to get, again, negative 3/7. So how do we know if these slopes are perpendicular? Well, we've mentioned before that perpendicular slopes will have a product that is equal to negative 1. And that is in fact the case. We get negative 21 over 21, which is negative 1. So check these are perpendicular. The only time this does not hold true is if we have a vertical and horizontal line, because the vertical slope would be undefined. The horizontal slope would be 0. And multiplying those two together would not get you negative 1. But for every other situation, slopes can be identified as perpendicular through multiplying them together and getting negative 1. Now, the other thing to look out for perpendicular slopes is if you flip one or take the reciprocal of one and change the sign, you should get the other slope. And that holds true. If we take the reciprocal of 7/3, we get 3/7. Change the sign, we get negative 3/7, which is in fact what we see here. So check, check, these are perpendicular. So we have a rhombus. Now, do we have a square? Well, if we have a parallelogram that is a rectangle and a rhombus, we have a square. There's no additional work needed. We just verified that all sides and all angles should be congruent through the verification that we have a rectangle, a rhombus, and the initial verification that we had a parallelogram. So if you're not told you have a parallelogram, you want to check to see that you do in fact have that first. Oftentimes they will say you have a parallelogram. Is this a rectangle, a rhombus, square? Select all that apply. And you don't have to go through that diagonal bisection part. But if you don't know, like in this problem, you just have points in a coordinate plane, you should check to see if you have a parallelogram first. In every case that we were using, we looked at the diagonals. That is the most efficient method. So there's the conclusion of the video on rectangle, rhombus, and square.